So this is one of my own personal amps. This is a 1976 Fender Vibrolux Reverb that I'm very grateful to own. I use this one mainly for jazz. And when I bought it, it was completely original, except that someone had added a homemade line out. They drilled a hole in the back chassis, which I've subsequently covered with this little stopper, and they had a line out from the phase inverter. So based on the components, it looks like they were it was early in the history of this amp, so probably at some point in the late 1970s that was done. Anyhow, I removed that, and I later did the necessary changes. So the filter capacitors have been changed, bias capacitor has been changed. This capacitor in the bias circuit was completely gone, so completely dead I should say, so I replaced that as well. And today I'm going to be replacing these cathode bias. Wait, now let me get a little pointer here. These white Mallory cathode bias bypass, I should say, cathode bypass capacitors. This 5 microfarad, and then there's a 25 here, and a 25 here, and two 25s here. So we'll be replacing those. And these ones here, which are signal caps, they should probably be replaced at some point as well, but they're not electrolytic, so they're less urgent perhaps. But anyhow, so the first thing that we're going to do is drain the filter capacitors, just in case there's some charge left up. I was using this amp at a gig last night, and I am just going to put that there to see what kind of charge is left on that. And so you can see there's 16.7 volts. That will slowly drain there, but I'm going to speed up the draining process with this little rig that I have, which is a high wattage resistor, and we will just attach that to ground. And in this case, you can really put it anywhere in the power circuit, but I'm just going to put it here at this plate. So that should cause that to, as it does, drain much more quickly. Look at it go. And it's just going to you're going to remain at 5 volts. It's going to drop down to 0 and then go back up to 5 volts again as it kind of recharges itself. But anyhow, that's certainly safe to work with. So we're replacing those white original Mallory capacitors with these modern Spragues. So I have 4 of the 25 microfarad and 1 of the 5 microfarad. So we'll be taking these out first. And you notice all this goop on this board, eyelet board. That's actually wax, and you can see it in particular sort of built up on some of these capacitors. So in those days, in the 70s, Fender used to, in Canada at least, used to simply spray all of their eyelet boards with wax to protect them from moisture and so on. But it does make working on them a little awkward. I mean, these point-to-point wiring is so much easier to work with anyhow, compared to PCPs, or PCBs rather. But when you have this wax all over the place, it does make soldering a little messy. So anyhow, we'll get through it. This is another cap that we have to remove. This again, cathode bypass capacitor that's attached to the tremolo circuit. Hiding in there, sort of snuck in there, unlike all these other ones that are right on the eyelet board. Okay, so we have the cathode bias capacitor from the tremolo circuit, vibrato circuit, however you want to call it, hooked up. Let's just test it. We have it out there, and we're just going to test it. This is not a particularly accurate tester, but it'll give us some sense of whether there's any sort of leakage supposed to be 25 microfarads. It's 34.6 microfarads and 3.5% leakage. So I have replaced all of the capacitors with the exception of these two, since I accidentally misordered and I only had 4 rather than 5. I think I forgot about this guy. And those two are in the normal channel and they're also a little hard to get at. So I'm going to wait on those. I will be replacing them eventually. And we'll just, well, I ran it on the Variac, make sure everything was fine. And we'll just test it now with the oscilloscope, with a test signal, make sure everything's okay. Okay, so we have our signal generator here. And we're going into the vibrato channel, the main channel that most people use because that has the reverb. We have a 4 ohm dummy load since we're not working with a speaker, and the oscilloscope is hooked up to the dummy load, and we have the amp itself plugged into a wattage meter that is going into a Variac, which is going into an isolation transformer. So we're going to turn it on, let it warm up a bit. Hopefully nothing blows up. Oh, and we'll turn on the oscilloscope. And we'll wait for a signal to come through there once we've come off of standby. So you can see the heaters are heating up on the power tubes. While we're waiting, I'll show you an interesting little thing. This little device here is a thermal fuse, and you only find that in the Canadian version of this amplifier because it was required by CSA. Okay, so now as this starts operating, we should see a signal start to appear. I'll turn up the channel a little bit. Oh. There's our signal. Yeah, we're going a little too. Let me slow that down a little bit. This big one here. Okay, now as I turn the volume up, we'll see it start to distort. We're pretty high there. I'm increasing the signal coming in. You actually start to hear that hum. Oops, sorry about that. Yeah, so anyhow, it seems to be working okay. Nice clean signal.